Unlike the rule of existential introduction, the rule of existential elimination is a bit difficult to grasp, so let me warm up to it just a little bit. Consider the following argument. All humans are mortal. Some things are human. Therefore, some things are mortal. I think it's clear that this argument is valid, but if we need to be persuaded that it is valid, we can persuade ourselves of that by going through something like the following bit of reasoning. According to the first premise, anything that is human is mortal. According to the second premise, some things are human. So take an arbitrary example of one of those things, that is, one of the things that is human. Well, since all humans are mortal, the arbitrary example of a human that we just picked is mortal. So there's at least one thing that's mortal, namely the arbitrary example of a human that we just picked. So some things are mortal. So I think this bit of reasoning ought to convince us that the above argument is valid. And what the rule of existential elimination essentially allows us to do is represent the kind of reasoning that I just went through in our system. Now note that one thing that I did when I went through this bit of reasoning is I referred to an arbitrary example of a human being. And that's one thing that we'll be doing, that's the sort of thing that we'll be doing when we apply the rule of existential elimination. So let me introduce a little bit of terminology here. Suppose one has a sentence with an existential quantifier out front. An arbitrary case of that existential sentence is a sentence just like it, except that the existential quantifier out front has been deleted, and each occurrence of the variable that the existential quantifier ranged over has been replaced by an arbitrary name. So let's look at a couple of examples. So an arbitrary case for there exists an x such that hx is ha. Note what I've done here is I've taken the first sentence, the one with the existential quantifier out front. I have deleted the existential quantifier and replaced the variable x with the arbitrary name a. So the original sentence may have translated something is human. What I've essentially done here is said, okay, pick, if something is human, let's suppose that's true, well then pick an arbitrary example of one of the things that is human and call it a. Well, a is human. Let's look at another example. An arbitrary case for there exists an x such that for any y l x y is for any y l a y. So perhaps the original sentence with the existential quantifier out front translated someone loves everyone. That is, there is some x such that for any y, x loves y. And what I've done then is I have essentially said, okay, let's suppose that's true. Well then pick an example of one of the individuals that loves everyone. Maybe there's only one such individual, maybe there's more than one, but pick one such individual and call it A. Pick it at random and call it A. Well, that individual is one of the individuals that loves everyone. That is, that individual is one of the individuals that is such that. That individual A is one of the individuals that is such that for any y, A loves y. Okay, so these are some examples of arbitrary cases of sentences with existential quantifiers out front. This is my own terminology. Your textbook uses different terminology for the same thing. Your textbook calls what I'm calling an arbitrary case a typical disjunct. It does that because it draws on an analogy between existential elimination and or elimination. That analogy is interesting and worth exploring, so if you are interested in that analogy, I encourage you to read what your textbook has to say about it. but I'm not going to explore that analogy in this lecture, and so I'm going to refer to what your textbook calls the typical disjunct as the arbitrary case. Okay, so now that we've got this terminology on hand, let's go ahead and state the existential elimination rule. Unfortunately, the rule is complicated, and that makes it quite a mouthful to state. Don't worry though, I will show you an example of how the rule is applied, and then we'll see a few more examples a little later on. Okay, so here is the rule stated. Suppose one has a sentence, there exists an x such that phi x. Okay, this string of symbols here, there exists an x such that phi x. This is a name for a sentence in the object language. It is a name in the meta language, the language that we're currently working with, namely English supplemented with a few devices, for a sentence in the object language, namely the language of predicate logic. And likewise with the other similar looking strings of symbols that you see here. Okay, anyway, getting back to the statement of the rule, suppose one does have such a sentence with an existential quantifier out front on one line. Now consider an arbitrary case of that sentence, phi a, where a is the arbitrary name that replaces the variable that the existential quantifier ranges over in the original sentence. Now suppose one also has another line containing a conditional of the following form: if phi a then c, then one may infer another line that contains c, provided that c does not contain the arbitrary name a, and provided that neither the line containing the original sentence nor the line containing the conditional depends on any assumptions containing the arbitrary name a. Okay, like I said, quite a mouthful, pretty complicated, but I think it's easier to grasp what's going on here if one sees the rule applied. So let's go ahead and look at an example of the rule applied. Okay, so here is a sequent. For any x, if x is h, then x is m. Something is h, therefore something is m. So this may translate, for instance, all humans are mortal, something is human, therefore something is mortal. This is a clearly valid argument pattern, and the rules we now have allow us to prove that it is. So, okay, let's begin by writing down our premises. On the second line, we have a sentence with an existential quantifier out front. That is, we have an existential sentence. Whenever one's working with an existential sentence and one knows that one wants to try to derive something from that sentence, it's good to go ahead and assume an arbitrary case of that sentence. So that's what I'm doing here on line 3. I am assuming an arbitrary case of the existential sentence that occurs on line 2. And what I do to get an arbitrary case is I simply delete the existential quantifier out front of the original sentence, and I replace the variable that that existential quantifier ranges over with a name. So I've deleted the existential quantifier out front, and I've replaced the variable x with the name a. Okay, now that I have my arbitrary case, I'm going to go ahead and apply universal elimination to line 1 so that I now have a sentence that has my arbitrary name in it instead of a sentence with a universal quantifier out front. Now that I've done all that, I'm going to consider what my goal is. My goal is to get the existential sentence, there exists an x such that x is m. And to achieve that goal, what I'm going to try to do is I'm going to try to derive a is m so that I can get there exists an x such that x is m via the rule of existential introduction. So here's how I'm going to do that. Watch how this proof unfolds. Alright, so I see that given lines 3 and 4, I'm in a position to apply modus ponens to get MA. So I've done that. Now I apply existential introduction to get there exists an X such that MX. Now that is the conclusion that I want, but unfortunately I'm not done, because you can see that I'm still dependent on line 6 on an assumption. I'm dependent on the assumption made on line 3. So what I need to do is discharge that assumption. So I'll go ahead and do that by applying conditional proof to lines 3 and 6. Okay, now that I have discharged that assumption, I have line 2 in which a sentence with an existential quantifier out front occurs. And I have line 7 in which I have a conditional that has as its antecedent an arbitrary case of the existential sentence that occurs on line 2, and that conditional also has as its consequent my desired conclusion. So as long as all the provisos to my existential elimination rule are met, I can go ahead and apply existential elimination to lines 2 and 7 to get my desired conclusion. Okay, I said provided that all my provisos are met, so let me back up and just examine things to see whether those provisos are met. So first, when I am applying the rule of existential elimination, I need to examine the consequent of the conditional that I use and make sure that the consequent of that conditional does not contain the arbitrary name that occurs in the arbitrary case. Okay, the arbitrary case is HA, so the arbitrary name is A. I need to make sure that my conditional does not, or the consequent of my conditional does not contain that name. Well, the consequent of my conditional is there exists an X such that MX, that does not contain the arbitrary name A. So I'm okay, I've met that proviso. I also need to check and make sure that line 7 doesn't depend on any assumptions that contain the arbitrary name A. Well, in that case, that's pretty easy to check because line 7 depends on no assumptions whatsoever, so it doesn't depend on any assumptions that contain the arbitrary name A. And I also have to check the line on which the existential sentence occurs, that is the sentence that occurs on line 2. I need to check that sentence and make sure that that sentence does not contain the name A or depend on any assumptions that contain the name A. I look at that sentence though on line 2 and I see that that is in fact the case, so all my provisos are met, so I can go ahead and apply the rule of existential elimination to lines 2 and 7 to get my desired conclusion. So I encourage you to look carefully over this proof. You will have some homework that will allow you to practice applying this rule. But before you do that, I'd like you to watch the next part of this lecture in which I show why it is necessary to stick to the kinds of provisos that we've introduced when we introduce the rules of existential elimination and also universal introduction. So go ahead and watch the next part of this lecture.